So once we've examined limits from a numerical perspective, we can also look at them from a graphical perspective. So even in the numerical perspective, if you've got a function and you make a t-table, right? If you had 1.9, 1.99, 1.999, and you got an a y value out, and let's say it was negative 1.59, negative 1.68, negative 1.99, negative 1.999, right? You'd be able to plot these as a point, right? Negative 1.9, comma, negative 1.59, negative, 1.99, comma, negative 1.68. You'd plot those points. And you would see that what was happening is that the points were headed toward a particular point on the graph, or a particular height, or a particular value on the graph. So if we have a graph of a function, but not the function itself, it is still possible to evaluate the limit. And one way to think of this is by using kind of this wall idea. And the limit is where you hit the wall. Okay, so in this case, we're going to draw in the wall at 2, right? So it says the limit as x approaches 2, and again, there's no plus or minus in the exponent area, so this means we have to check both directions. So I'm going to draw in the wall at x equals 2, right? The vertical wall at x equals 2. And then I'm going to come in on the graph from the left of the wall. From the left side of the wall, I'm going to just pick somewhere on the graph, so let's say up here, and then move toward the wall and notice where I hit the wall. Okay, I had a height of 1. So that's the limit as we approach 2 from the left. Now I'm going to do the same thing. I need to approach the wall from the right. Again, start somewhere to the right of the wall on the function graph and move toward the wall. And where do I hit? Again, at positive 1. So the limit from the left, right, from this side, as x approaches 2 from the left of f of x is 1, and the limit as x approaches 2 from the right of f of x is 1. So this limit equals 1. Let's try a few more here. So I'm going to focus in on the limit as x approaches 2 of f of x, where f of x has a point moved. And remember, the idea of a limit is as I approach 2 from the left. I don't care what's really actually happening at 2, because remember, all of our sequences, we kind of approached 2. We never actually got to 2 or 0 or whatever value we were looking for. So I'm going to use that same idea. I'm going to make my wall. Draw in my wall at 2, and then approach from the left. So again, start somewhere to the left of the wall on the graph, and then head toward the wall while I'm on the graph. And I hit a height of 1. Now, it doesn't matter there's a hole there, right? Because we're just looking as we approach. So even though there's, a hole in the wall there, that's okay. I would eventually hit the wall at 1. And then same thing, starting just from the right of the wall along the graph, and I hit the wall at 1. So this limit is also 1. So even though that point has been moved, displaced, it doesn't matter. The limit, the sequence of y values, the sequence of the heights that I'm approaching is equal to 1. Right, so we have a slightly different one here. We have a vertical asymptote. So I'm going to, again, draw in the wall. It's sort of drawn in for us with the vertical asymptote. And then I want to take and do the same thing. I'm going to start on the left side of the wall, somewhere on the graph, and then move toward the wall along the graph. So I'm going to start here on the wall, and I'll move toward the wall along the graph. And notice what happens. What is the limit as we approach 2 from the left of this function? This is negative infinity. Okay, So now let's check the limit from the right. Again, I'm going to start on the graph on the right side of the wall and then move toward the wall along the graph. And this limit, as we approach 2 from the right of our function, is positive infinity. So the limit from the left does not match the limit from the right, and when that happens, we say that the limit does not exist. Okay. We've got one more graph here, so let's take a look at that. Okay, part A. Again, each of these is as x approaches 1, so I'm going to put in my wall at x equals 1. Okay, and again, the idea is as I approach the wall, what height am I attempting to hit the wall at? All right, so the limit as x approaches 1 from the left. So look at the wall, start on the left-hand side, on the graph somewhere along the left-hand side, and then move toward the wall along the graph. And the height I would hit the wall from the left would be 3. Limit as x approaches 1 from the right. Again, start on the graph that is on the right side of the wall and move toward the wall. There, I hit a height of -3. And because these are not the same, our answer then to part C is does not exist. Okay, so here our goal is to decide if these statements are true or false, and I would add if they're false, fix them so that they would become true. Okay, so we're going to add that to the directions in this particular problem. So let's do them one at a time. Letter A, limit as x approaches 0. So put in my wall at 0. So 0 is the y-axis. Y equals 0 is the y-axis. So I'm going to put that in. Okay, the limit as x approaches 0. There's no plus or minus up here. So that means I have to check both the left and the right. So as I come in from the left of 0, the left of the wall, along the graph, and move toward the wall. From the right side I hit 2, from the left side I hit 2. But what happens when I come in from the right? I hit -2. Do I end up at the same location on the wall, the same height on the wall? The answer is no. So this is false. Okay. How would I fix this? Well, in order to make the answer true, I would either have to change this to the limit as x approaches 0 from the left, right? I could either do that, or if I don't do that, you just say this does not exist. Okay, so either one of those would work in terms of making that a true statement. All right, letter B. We're still approaching 0, and we're approaching from the right. Well, we already did that. Approaching from the right is down here, and then moving along the graph toward the wall, and we hit the wall at -2. So this one is true. Okay, so let's clean that up and go to the next one. All right, letter C, limit as x approaches 2, and there's no plus or minus, so it means from both directions. So I'm going to fill in my wall at 2. Okay, and then approach from the left. So starting somewhere to the left, oops, different color, to the left and move toward the wall. I hit the wall at the x-axis, so at a height of 0 on the wall. And then on the right-hand side, if I start there and move toward the wall, I hit the wall again at a height of 0. So the limit from the left is 0, the limit from the right is 0, therefore the limit is 0, and this is a true statement. Okay, letter D, the limit as x approaches 3 of f of x equals 1. So the limit as x approaches 3, that tells me where to put my wall at 3. And then I want to come in from the left of 3 and I'll move along the graph toward the wall. I get a height of 1. And then also starting from the right and moving toward the wall, I also get a height of 1. So letter D, that is a true statement. The limit is 1. Okay, letter E, f of 3 equals 4. This is asking me now, not what happens near 3, but what happens exactly at 3. And that's really highlighting the difference between a limit problem, a limit question, and a function value question. So a function value question is asking me what happens exactly at 3, whereas part D was what is the limit as x approaches 3, right? So we're noticing the difference between those two problems. Notice the limit was 1, but if I plug in 3, is my height at 3 equal to 4? Do I have the point 3, 4 on the graph? That's really what it's asking. And if we go to 3, and there's a hole here, so that's not where the y value is. So we end up going up here, which gives me a height of 4. So this is the point 3, 4. So at 3, the function value is 4. So that's a true statement. Even though the limit, as I approach 3, it wanted to reach a height of 1. But that's not what the function value actually is. Okay. And then last but not least, letter F. Okay, letter F says the limit as x approaches 3 from the left is 3. Well, if we look at part D right above, we already determined that the limit was 1. So that meant the limit from the left and from the right is 1. Therefore, the limit as x approaches 3 from the left cannot be 3. That's false. And in fact, the correct answer would be 1. If you don't see that, you can go ahead and do the wall at 3 and then move along the wall from the left of 3 toward the wall. And where would you hit the wall? You'd hit the wall at 1.